One of the ways that we can find the Boolean expression that is generating a particular truth table is called the sum of products. So let's say, for instance, that we have this truth table with variables x and y. And I have the output column f of xy that is generating 1, 1, 0, 0. What I'd like to do is to identify the min terms that are generating an output of 1. Those are going to be the only ones that I want to concern myself with. And so we have two outputs. We have two 1s on my output column. And so I would like to evaluate what is generating those two outputs. And so what I can see here that we have an x equal to 1 and we have a y equal to 1 right there. X is a 1, a y is a 1, and that is generating the 1 on my output column. So because x and y are both Boolean variables, I can tell that x equal to 1 is x and y equal to 1 is y. And I'm going to multiply the two of them together, xy, which is going to give me, if I put the two of them side by side, that's implied multiplication. So let's look at the next one. There is a 1 that has been generated here. I can see this is x equal to 1 and y equal to 0. An x equal to 1 is going to give me x, but a y equal to 0 is going to give me x naught. So I'll put that not operator up there. If I imply the multiplication, I can put x, y, naught. This is the product of the xy values that is generating that particular min term. So now we're going to do the sum of the two products. So if I add the two of them, the two products together, I'm going to get xy plus xy naught. And this is, without even simplifying it, this is going to be the function f of xy that is generating that output column that I just gave you, xy plus xy naught. Now I could simplify this a little bit farther by factoring the x out of both of them. That would give me y plus y naught. My simplification rules tell me that y plus y naught is equal to 1. So this is going to give me x times 1. And I know that x times 1 is x. So ultimately, this is the function that is generating this particular output column on that truth table. So let's do another one, a slightly larger one. So let's say that we have this truth table that contains x, y, and z. And there is some Boolean expression, some f of x, y, of z, that is generating this particular output. So we want to look at the output column and we want to find the min terms. Those are the rows that are generating 1s. Those are the only ones that I want to concern myself with. And then we want to see if we can find the values of x, y, and z that are generating those min terms. Let me move this up a little bit to give myself a little bit of space. All right, so this particular row is generating a min term, which is an output value of 1, and I can see x is equal to 1, y is equal to 0, and z is equal to 1. That is going to give me x, y naught, and z. The next min term is x equal to 1, and both y and z are equal to 0. That is going to give me an x, a y naught, and a z naught. The next one has an x equal to 0, but both y and z are equal to 1. So that is going to give me an x naught, and then a y and a z. The last one actually has all x, y, and z are all three equal to 0. So ultimately this is going to give me x naught, y naught, and z naught. So now I'm going to take each one of these four min terms, these products, and I'm going to do the sum of the products. So I'm going to add the four of them together. So let me put them down here. The first one is we'll have x, y naught, z, and then I'm going to add to that x, y naught, z naught. Then the third one is x naught, y, z, and the last one is x naught, y naught, z naught. So this is ultimately the function f of x, y, and z that is generating this particular output column for that truth table. How about if we simplify it just a little bit? If I look at these two, I can see that they have an x in common. So why don't we factor out the x? And then if I look at these two, I can see that there is and x not in common, so why don't we factor those out? Very good. Now if I look at this, I see that those two terms actually have a y naught in common. So I am going to factor out the y naught. Now it would be nice if this had a y and a y naught, but it doesn't. So I'm just going to bring that down. X naught, yz plus y naught, z naught. Let me move this up just a little bit, because when I see this, I see the z and the z plus. I know from my simplification rules that that equals 1. So this is going to give me x times y naught times 1, which is x y naught, and then plus, I can just drop this down, yz plus y naught z naught. And this is going to be a simplified f, y, and z that is going to be generating the output column.